The table gives the life expectancy for American women during the years 1930 through 2000. We're asked to first define variables. I will let T represent the year, and I will let capital L represent the life expectancy of American women. We're now asked to graph the data on a scatter plot and find an eyeball best fit line. So I will use T and capital L. I'll put a break in the axis and we'll start at 1920, and 1930, 1940, 1950, through 2000. And then for the life expectancy, I see a minimum a little bit more than 60 and a maximum is a little bit less than 80. So what I will do is put a break in the axis and we'll start at 55, and there's 60, 65, 70, 75, 80, 85. All right, 1930, we have 61.6. So that's about here. 1940, 65.2. 1950, 71.1. 1960, 73.1. So let's see, this would be 72.5, so 73.1 would be 1960, 73.1. So 1960, this would be 72.5, go a little bit higher, there's 73.1 roughly. 1970, 74.7. 1980, 77.4. And 1990, 78.8. And finally 2000, 79.7. Alright, so we've got these data points. We're asked to find an eyeball best fit line. I guess I should have said that here's the year and this is the life expectancy. And that life expectancy is also in years. Alright, so we've got these data points, and what I would mention here is notice that these, the later points, these 6 points, seem to follow a pretty good line, and these other 2 points, the first 2 points, don't. And so even though we generally want to try and get as many points as possible on or near the line, in this case, what I'm going to do is I'm going to focus on the second grouping, the grouping in orange. I'm going to draw the line that best fits those. And I guess the reason why is it's more recent data, and I would expect it to provide more reasonable conclusions than including those first 2 points. So I'm going to focus on the later data, and it looks like if I go through this point on 1950 and the point on 1990, I think that'll give me a pretty good line. So there's the line I'm going to use for my best fit. And again, I'm purposefully, in a sense, leaving off those first 2 data points. I'm going to focus on the later 6 data points, and specifically the line that I drew went through the 1950 data and the 1990 data. We're now asked to find the equation of the linear model. So I'm using the points for T and L. Those are my ordered pairs, and I use the 1950 data. So 1950, 71.1, and the 1990 data, so 1990, 78.8. Find the slope. M is equal to 78.8 minus 71.1 over 1990 minus 1950. Go through the arithmetic here. 78.8 minus 71.1 is 7.7. And 1990 minus 1950 is 40. 7.7 divided by 40 is 0.1925. I'm going to go ahead and approximate that as 0.19. Alright, so now using the point slope form, I can write L minus 71.1 is 0.19 by t minus 1950. Applying the distributive property. And let's see, 0.19 multiplied by 1950 is 370.5. And I will add on 71.1. Don't forget the t here. So 0.19 t. And let's see, negative 370.5 plus 71.1 gives me negative 299.4. Alright, so there's the model that I will use. Using the model, estimate the life expectancy for American women in the year 1900. If necessary, round the answer to 2 decimal places. And is this answer reasonable? Right, so let's see. The year 1990, so we'll let t equal 1900. So then the life expectancy would be 0.19 by 1,900 minus 299.4. We'll go through the arithmetic here. 0.19 by 1990 is 378.1, and we'll subtract from that 299.4. And that gives us I made an error in my calculation here. 1990 by 1900, 0.19 by 1900 is 361, and 361 minus 299.4 is 61.6. Alright, so this is telling us that in 1900, the life expectancy of American women was 61.6 years. And it says, does this seem reasonable? Well, honestly, I don't think so. And if we sort of think about when we drew that line of best fit, we purposefully left off those 2 points that were towards the left. And, look, in 1930, the life expectancy was 61.6. And we should expect the life expectancy to increase somewhat over time. So in 1990, I think it should have been less than 61.6. So I'm going to say, I don't think this is reasonable. Using the model, estimate the life expectancy for American women in the year 2100. If necessary, round the answer to 2 decimal places. Is this answer reasonable? Alright, so we'll let t equal 2100. And so then L would equal 0.19 by 2100 minus 299.4. And we'll go through the arithmetic. 0.9 by 2100 is 399 minus 299.4. Let's see, 399 minus 299.4, it's what, 99.6. So this is saying that in the year 2100, the life expectancy of American women will be about 100 years. Is that reasonable? Well, I'm not sure. I think it would be difficult. I think it will be difficult for the life expectancy to be near 100. So I'm going to have to say that I don't think this is reasonable. We don't know if the life expectancy will continue to increase. At the same rate. In general, when you're creating a model, it's best to use that model near the data points. You don't want to go too far in either direction from the data you already know. So maybe estimating out to 2020, that might give you a reasonable estimate. But to go much further than that is very difficult and generally produces unreasonable answers.